This presentation is about multicolor 3D printing in clay. It's also about a 5+ year journey in exploring 3D printing for clay more generally and taking an individualized approach to that. I first got interested in 3D printing quite a long time ago. I think I was introduced to it as a concept in graduate school, but in a more relatable way, in 2008 was the first time I was able to print a plastic object from a design that I had created in a computer modeling program. And holding that object in my hand in 2008 was a really meaningful experience for me personally. And I had this sense, very strong sense, that this is a process I'm going to be engaged with for hopefully a very long time. And I also, at that time in 2008, had a little bit of frustration because I felt like this was a very expensive process to engage with at that time, and I wasn't able to run the printer myself. I didn't know much about how it worked, and I wasn't going to be able to make a lot of prints or have a lot of access to that. So I had to sort of wait for a while and wait for the technology to become more accessible. In these videos, which will move along in a chronological fashion, are all sort of snapshots from 2015, which you see here with my very first attempt at making any kind of clay printer at all. And in this case, it was really just a syringe and some gears. And when the gears turned, it was successful in just dumping some slip onto the table. But it wasn't particularly successful in doing anything else. And so as I got more familiar with 3D printing in plastic, I, over time, just knew that I wanted to start working with the idea of printing directly in clay. And so in 2015, I was able to begin working with a program at Penn State University where I teach in the College of Engineering called the Learning Factory program. And I was introduced to that by Dr. Tim Simpson at Penn State. And the Learning Factory program paired students like these who were helping me design an extruder based on an open source design that was out there in 2015. It paired these students with a sponsor, sometimes a corporate sponsor, but in my case, a university sponsor, to try and explore an engineering problem as a group. And so we started, with a very basic controller board and power supply that you might have on an ordinary printer. We weren't even trying to hook this up to a printer. We're just trying to make an extruder that would move clay and would also have the ability to stop and start that extrusion. And so the first attempt used air pressure, and for a number of reasons, we weren't totally sold on that, and I kind of went back to the drawing board myself and just started conducting some of the dumbest tests you could imagine, just to see how you could use mechanical force to move a thick fluid and to extrude something. And so these tests started maybe a little bit crudely, just using an Arduino and some PVC pipe and pushing some really wet terracotta through a hose. Again, this is not controlled by any kind of printer or anything like that, but just thinking about what does it take to extrude clay mechanically, and how much control could you have over that process? And ultimately, the really key thing was, could you have some sort of parity with the quality of print that we had come to expect with the plastic FDM printers? And so in a series of iterations that are just endless, that just went on and on and on, we just tried one method after another. And gradually, with this hooked up to a 3D printer and with this working reasonably well, we started to make some progress. But controlling the extrusion mechanically was hard. It was hard to stop and start, speed up and slow down the rate at which the clay was coming out. And it was also hard to just synchronize everything. There were obviously plenty of precedents that we were looking at. We were aware of the work of Dries Verbruggen in Belgium and Jonathan Keep in the UK. Both of them had begun working with clay printing in about 2009 or 2010. And so by 2015, they were relatively adept at it. And Jonathan had even released a open source printer design based on a Delta platform using air compression as the means of moving the clay. For whatever reason, I just really wanted to explore a different approach to this. I didn't like, as I mentioned, the air compression, and I had already been building plastic printers in a Cartesian format. And the Cartesian format, which is a little more box-like than the Delta, was really good in my mind for the type of sculptural form that I wanted to make. And it'll sound ridiculous, but if I've done anything innovative at all with my research over the last 5 years, it's this experiment here, in which I was using something called motor mirroring to make these two motors turn in a way that is synchronized, meaning that they stop and start at the same points, but that they turn different amounts. And so you could change the rate at which they turn independently. And why that was important, and I don't think I'm explaining that super well, but it's in action here, is that we settled on a design that used both a small screw auger in the print head to push the clay out, and then way back behind it, which you will be able to see here in a moment, we had a very large sort of mechanical syringe. And so it became very important that both the auger and the mechanical syringe would move in unison, so that if the big mechanical syringe didn't pause when the auger paused, it would overwhelm the auger with clay. And if the auger was spinning to try and release clay, but the big mechanical syringe was not, it would sort of run out of material to dispense onto the print platform. And so originally I had been very interested in adapting this to a style of printer that was an open source design based on the Prusa i3 design, which is a very popular open source 3D printer. And while this worked well, it had a lot of limitations, one of which I really disliked the hoses that the clay was running through. So I made this build platform that would move the print bed in both the X and the Y axis. And then the idea here was to have a Z axis, the up and down axis, that would move up and down. And so the print bed, where the object gets deposited, would move all around, left, right, front, and back. And then the print head, or the extruder, would simply make a drawing layer by layer and stack those layers until you had an object. There are disadvantages to this approach. In a Delta format, for example, the print bed doesn't move, which is a great advantage. But a couple of things I really liked about doing it this way was, the main thing was I wanted to keep the clay as close to the print head as possible. And I also knew, as a sculptor who wasn't interested in pursuing vessel forms, that I wanted a layout that would not have a circular build volume and wouldn't prejudice height over width, but would be a little bit more cubic and perhaps a little bit capable of doing a wider rather than a taller print, just knowing the types of sculptures that I was inclined to make. And over time, this became more reliable, a little bit cleaner, and we started to get some forms that could really be used, could really be made into the kinds of sculptures that I wanted to be making. And all of this is playing out, over a period of many years. 5 years to be exact, 5.5 years perhaps. And so the iterations just kind of keep coming and coming. And one of the things we think about all the time is how the clay gets from where it starts to where it ends up as part of an object. And to make that pathway a pathway of very little resistance, and to try and avoid any kind of a bottleneck or any kind of a unnecessary friction along the way. And so through experiment after experiment, we ended up with elegant prints and, really inelegant prints like this one that just has all kinds of kind of lumpiness to it. But the whole point here was to work with a fairly stiff clay that we might just be able to make this kind of bridging form that would kind of arch right over this opening. And while this looks terrible, at the time, it felt like something significant. And this whole research effort, beginning in 2015 and ongoing now, has been really exhilarating, but has also been really tough in the sense that any other mode of working that I was engaged in really kind of stopped because I have had to devote so much time and headspace to kind of working through this. And I find that all very exciting. But at the same time, there's been this long gap of sort of, making a certain type of body of work and then needing to develop a new way to work, wanting to develop a new way to work, wanting to make the tools in a specific way that meet the needs or the ideas that I have in my sculpture and the limitations that I kept coming up against in my sculpture. And then that really significant challenge of once the tool starts working the way that you maybe want it to work, how to get back to the bodies of work that one wants to see in the world, and maybe even how to just sort of get past the fact that they're made using a whole constellation of sort of digital fabrication tools, both in the making of the clay printer and in the way that the clay printer creates the sculptural works themselves. And so most recently, that vision has really started to play out, but it's been years and it's been fascinating and it's been really something. And so along the way, we've worked with all kinds of plywood, aluminum, in this case plaster, making a build platform for the objects to be printed on top of, and tried all kinds of different methods of things as mundane as just loading the clay, as we're doing here, into a large tube. Often that's done by hand. Other times we use a wall-mounted extruder like this. And everything has been a lot of trial and error, but then also a lot of collaboration. And so I mentioned the Learning Factory program. I think we worked 4 or 5 different semesters with that program. And that probably is a total of somewhere between 25 and 35 students who have contributed to what I would call a very personalized, very specific approach to 3D printing with clay. And so early on, we started to think about where we wanted to take that. One of the crucial decisions that we made at the very beginning was whether or not we should just buy a clay printer that existed in the marketplace. And in 2015, there were just a couple early companies who were producing clay printers, or if we should start from scratch. And our decision to start from scratch, to start with an open source printer design and really kind of just build from the ground up, was a really fundamental decision, and one that has led us to where we are now, but has also been really not a decision I questioned much at all, because the process has been fascinating. And most recently, the results of that process, or the residue of that process, has become increasingly more compelling for me personally, and I hope for potential viewers and observers of this process. So as we went along, we started to think about how this relates to other ways of working with clay. And as I mentioned, I had been doing tons of mold making, and I stopped doing that entirely when I started printing with clay. And I hadn't been doing much hand building at all, but I didn't continue doing much of that. And I really have just thrown everything into this process and been continually sort of fascinated and delighted, and also excited with where it might go. And so that leads to a lot of thinking about, what is clay printing, and what could it be, and does it replace something? Does it just augment what we already have? And I think these are open questions, and open questions that are really good to have. And so the obvious precedent for it is coil building, especially if you look at a process like this kind of bridging test on screen here, where this is a coil that's being extruded, and perhaps this coil is 2 or maybe 3 millimeters in diameter. So it's small relative to coils that we're familiar with, but it's large relative to, it's humongous actually, relative to FDM plastic-based consumer additive manufacturing or 3D printing by extrusion. And so the genius of coil building, as everyone who has ever tried it knows, is that you can make just about any kind of a form, whether it's geometric or vase-like or an animal form or a human figure, as long as you're able to visualize what that form would look like if it was broken down into a number of individual slices, and that those slices become drawings that become stacked upon one another. And so that's all a 3D print is a stack of drawings, each placed upon the one underneath it. And so what really connects this to a ceramic tradition is the coil building process. But I also was finding over and over, especially as we pushed the resolution a bit, was finding this connection to slip casting as well. And slip casting was something of a specialty of mine for a number of years prior to getting involved with clay printing. And so what I was seeking when I began working with slip casting was a kind of precision that I wasn't getting in my hand-built forms, or that I was getting, but only through somewhat extreme measures like sanding the clay or carving it after it had been formed. And so I knew that I wanted to work with sort of abstract forms, and that I wanted to work with geometry, and that I wanted to have kind of crisp edges to things, and that I wanted to also be very sort of deterministic and have a great deal of specificity about the forms that I was making. And all throughout, I had been learning since about, for the last 10 or 15 years, have been learning and working with 3D modeling programs, and becoming more fluent with them and more interested in realizing the forms that I could make in a 3D modeling program a little bit more directly in the clay. And so as we went along, we were looking at this as I started to feel like this was a little bit like slip casting, but without the mold. And what I mean by that is that the print could have all the precision of a slip cast part if it had a high enough resolution, and it could have the reproducibility of a slip cast component as well, but it didn't have the mold making experience, and it didn't, much more importantly, have that sort of locked down aspect of form when you commit to a mold pattern. That sense that once that mold pattern is sort of determined, the form is set, and the mold itself is a large object that is locked in. And so we had successes and failures in the process of developing approaches to this. Obviously, looked a lot at other makers working with clay printing, looked a lot at people building DIY and kind of custom approaches to plastic printing as well, and benefited a lot from getting to know Jonathan Keep and talking to him about what he's doing, working with other people on online forums for clay printing, chatting with Brian Serra and his developments in clay printing, and just visiting different programs where people were interested in this, seeing that the level of interest seems to have sort of steadily risen, and to just kind of build on iteration by iteration, bit by bit. And an important decision for me personally was to try and really shrink down the size of the extrusion. So what you see here is a print nozzle that is about a 0.5 millimeter in diameter, and that is basically in a parity with a plastic FDM printer. And so the idea has been to just match up diameter to diameter and capability to capability and process to process with a plastic FDM process. That's my personal approach. Obviously there are tons of different approaches to clay printing out there. As I mentioned, along the way, I got to know Jonathan Keep really well. He came to Penn State. Jonathan is based in the UK, and this is maybe 2 years ago. He was demonstrating his process of modeling via scripting, and in this case, a vase whose form is determined by the sound of a bird. And from that point, from before that point until now, Jonathan has been a constant sort of sounding board for ideas and just a great source of information for this, even though I think we're coming at it from different angles, which hopefully are sort of beneficial. And so, because my work has always been interested in the built environment and architecture and a sense of place and a sense of structure, I've built the printer to try and match that. And so as this video goes along, I think you can suddenly see that the extrusions are so much smaller and the details in the work are so much greater, and that is something that has continued on from iteration to iteration and from year to year. And so everything comes with trade-offs, and one of mine has been that I'm super interested in trying to shrink down these layer lines to the point where we more or less don't see them, in the same way that we more or less don't see the layer lines in printed plastic forms, at least not super clearly. And that, precludes a lot of work with that really celebrates in a way the extrusion, or really highlights the coil patterning that can happen when you're using a larger sort of print diameter. And so because we were thinking so much about coils and coiling, I think it was maybe inevitable that eventually I was going to think about color and wanting to try the idea of a second and maybe multiple at some point colors in the clay. And of course, anything made out of clay could be glazed or underglazed or painted in one way or another to be multicolor. But I was really interested in this kind of what I would call structural color. And so this was an early attempt, one of our first successful prints with a 2-color machine. You can see it's quite sloppy, kind of gloriously sloppy in a way. Now that we've got this under control a little bit more, I sort of miss how chaotic this was. But at the time, it was rougher than I would have hoped. And something appeared in these objects as we went along, which was that I've started to feel like they had a relationship not to painting as much as they had a relationship to weaving, and that the structural color layered on top of each other or next to each other was a really interesting opportunity to explore a way of working that did sort of celebrate this kind of color as material and a kind of texture and a kind of materiality that I just couldn't think of another analogy that was better than textiles and the craft of weaving. Technically, we came into some issues, or we had some problems, because this first iteration of a multicolor printer, you can see that both extruders are sort of locked in place. So they don't move independent of each other. And so while the one on the left is printing, the one on the right invariably is bashing into something, or at least lightly scraping the surface of what is being printed. And so that was a constant issue. And even just getting them calibrated to be the exact same height was quite difficult, given that there was no way to really move them independently. And so this first iteration was just a tremendous amount of work, and a number of engineering students from the Learning Factory program and myself worked on this really tirelessly. And while we were super excited with the result, I think we also knew that to do this well, we were going to have to push it a little bit further, and that the key item or the key direction in which we would have to push would be to separate the two extruders from each other and give each one its own independent sort of z-axis that it could move up and down along. And so that's where we went with a whole new sort of iteration of the tool. But before we did that, we did manage to get the extrusion size on this original design down to something that was a little bit more like what I wanted to use in the work. And so where we ended up is where we began this conversation with this newer printer that has two independent print heads. And so you can see here that this one print head is depositing material, and shortly that will lift up and the other print head will descend down and deposit clay on its own sort of axis. So this print head lifts, the object moves, the other print head comes into view, it drops down, and it begins extruding as we go. And so this new printer is actually also smaller, and I think I've been counterintuitive in this way, in that I feel like whenever I talk to people, especially outside of our School of Visual Arts, like if I'm speaking to someone in architecture or engineering, invariably they always want us to push the clay printing to a larger scale. But maybe because of who I am and what I'm looking at and what I'm interested in, I've gone the opposite direction and kind of have pushed this into a smaller scale. And a lot of that, again, is about trying to get a finer resolution, trying to get less visible layers, and trying to interweave these colors more tightly in a way that has a little bit more finesse to it. And it's an ongoing process. So this is a second iteration of a multicolor clay printer, and we must be on at least, I would say, our 10th iteration of a sort of DIY clay printer in the meantime. And they keep getting better, but it's a journey, it's a process, and it's been a few years, but we're very excited to explore this territory, very excited to think about this idea of structural color, and very excited to think about not just how this relates to existing ways of working with ceramics, but maybe more importantly, to think about different types of forms, to think about different types of coloring those forms, just to think about expanding, hopefully, a little bit the vocabulary of what we can do with this material, and not to try and duplicate the forms of the past with this, not to just make a number of cups in a style that we would recognize, but to work with sculpture and to work with a level of detail and clarity that maybe we associate with slip casting, to work with a level of free-form flexibility and capability that we maybe associate with coil building. And lastly, to work with a kind of structural color and ornamentation that we have to look outside of our field of ceramics. And again, for me, that the best reference would be textiles and weaving and the interlocking of materials with their own color and texture.